Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# User Group. A little bit about the group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. Essentially, the premise behind the user group is to have knowledge base experts that are working out in the field to be able to present on a specific topic. And you can find all the meeting information posted at meetup.com at the link listed at the bottom of the slide. This meeting wouldn't be possible without our sponsors, so we'd like to give a big thank you to the .NET Foundation and NIS Technologies for sponsoring the virtual meeting space. If you're joining us for the first time, please keep in mind participation is encouraged. And I always say the only stupid question is the one not being asked. So always feel free to jump in with a question or a comment. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we want to keep it casual but organized, meaning always feel free to chime in, but at the same time, we want to give our presenter enough time to go through the slides and the demos. And the presentation is being recorded and will be posted on YouTube with the link provided at the end of the presentation. So for tonight's feature presentation, we have new-ish C# language features by Matthew Hess. Matthew is a principal software engineer at CG Infinity. He joins us from the Albuquerque, New Mexico area, where he runs the Albuquerque .NET Users Group. And he's been working with C# since version 2, which was released back in 2005. He's worked with a variety of different organizations, developing software for legal, financial services, biotechnology, and nonprofit industries. You can find a lot of his videos at youtube.com/@C#artisan. And with that, would like to welcome you, Matt. Welcome to the C# User Group, Matt.
Thank you, Sam. Right on. And thank you all for joining. Let me select the content I want to share here. There we go. Okay, so before I begin, just a couple words about me. I am just like you guys. I'm just a programmer who has to figure stuff out occasionally. And sometimes I have a knack for telling bad jokes. My career in stand-up didn't really take off. So this is the second best thing. And I call myself the C# artisan. So what's up with that? That's a little arrogant. You know, what's going on there? So sometimes people ask the question, is software development an art or a science? And my answer for me is it's neither. I know there are real computer scientists doing actual research in things like AI and quantum computing, and I respect what they do. Those people are way smarter than me. It's amazing. And if you're a programmer, I'm sure you can relate to the artistic side of it. We all sometimes feel like there's a creative, aesthetic, artistic side to writing good, elegant code. But day in and day out, year after year, mostly I get paid to make stuff that works, to build things. So I view it as a craft. It's artisanal. And where I get joy in this is just helping other people like me kind of level up and get better at the craft of C# programming. A lot of people can cobble together code, and now with AI coding assistants, a lot more people can. But to be good at this, you really do have to pay attention to the details. So that's what this is all about. That's what the whole C# artisan thing is about. And specifically, today's presentation, which really needs to be sung, not spoken, right? Because these are a few of my favorite newish C# language features. So I'm not a very good singer, so that's why that other career went to the wayside. But the point of this topic is really just to help us keep up. I actually left C# programming for a while. I did it, then I hung up my compiler. I spent about 10 years doing other things with lasers and traveling the world and very interesting science stuff. And then I came back to it and I realized I had fallen behind. And Microsoft had done a lot in C# that I need to catch up on. So I kind of went on this journey myself of discovering all this cool new stuff. And it is cool. So I think this really can benefit people who are new to the language And to them, this is just C#, but maybe you haven't discovered some of these, but it could also really benefit some of us more experienced and older people who might be a little stuck in our ways, right? Because your old code still compiles. And old habits die hard. Like, why learn a new thing when the old thing works? So this is my way of just kind of guiding you around some of the new stuff. And right before I begin, I also want to say, if you want to turn your camera on, if you feel like you're going to join me and Mo here and be visible, that's fine. I do, my camera's here, but I can look over and see you guys here. And if you're smiling or snoring or have slipped into a coma, that helps me know, what to do. So feel free to turn your camera on. Also, if you have a question, just pop it in the chat or even just turn on your microphone and interrupt me. That's fine too. I'll try to pause at various times so that we can have that.
Yeah. So how was it?
All right. I heard Keith. Keith, your mic is working.
They're gonna take some of
But
his
you might have
blood
some background noise there.
and put him in his knees.
Hey,
There you
Matthew,
go. Yeah.
I wanted to point out Mo had his hand raised.
Yeah.
Did you?
Mo?
Oh,
I
thank
did.
you. Already a question. Yes, sir.
Yeah, my question is, you mentioned you left for 10 years. Personally, I'm still stuck in .NET Framework 4.7 something blind. When did you leave and when did you come back? And have you learned everything that happened in between?
I'm sure not. I'm sure the answer to the second half of that is no. But when I left, so I was still involved, but not actively coding. I just moved to a different part of the organization I was in. So that window was 2014 to 2002. I think I was really away. 14 to 22. I was kind of away. And yes, the last production code I had done before was .NET Framework 4 or 3.5 maybe. It might have been 3.5. And when I came back, .NET Core and then all this new stuff was happening. So I feel like I'm not writing any more .NET Framework code. When I start new projects, I just start with .NET 8 or now .NET 9. That's where we start. And that all of the early switchover pain I got to sort of miss. So, okay, let's get rolling into these slides. Just a couple quick acknowledgments. I want to thank my Uncle Mel. I have no idea where I'd be today without this guy. Thank you, Uncle Mel. You're the best. That's a joke, by the way, just so you know. I want to thank my employer, CG Infinity. This is an amazing organization. It's a software consulting shop out of Dallas. It's a great place to work, and they are super supportive of this kind of activity. So thank you, CG Infinity. And I want to thank you guys, the Cleveland C# User Group, for the invitation. I love doing this. I hope you like it, and thanks for making it possible. All right, so it's all going to be actually in Visual Studio, but here's one slide just to give you the menu of what we're going to cover. I want to talk about pattern matching switch expressions, which were introduced in C# 8, target typed constructors, which were introduced in C# 9, value tuples or tuples. There's an ongoing debate over how you say that. I kind of go with tuples because it sounds cute. But tuples sounds like multiple, so maybe that's better. Anyway, those are useful. C# 7. String interpolation, C# 10. Collection expressions, especially with this spread operator in C# 12. And null conditional assignment, which is in C# 14 preview, which is really cool. And all of this, oh, by the way, I should have mentioned, if you want to take a picture of these QR codes, you can get to my LinkedIn or my YouTube. And for the GitHub, I don't like to do a QR code. Whoops, where did it go? Let me get back to that last slide. And the last slide has where the code repo that actually has this project. So github.com /artisan favorite new features. And you can just go get the source code for yourself. Okay, so let's take a look at this source code now. This is just a little console app. And when you run it, it just gives you a little menu of items. And then the idea is when you're running it yourself, you just set breakpoints in the various functions you want to examine. So if you want to look at the value tuples demo, you would do number 3, and it's going to run a few functions, and you can step through them. So rather than stepping through code, let's just read the code. It's really very straightforward. And we're going to start with pattern matching switch. So just for comparison, let's just review what an if-then statement looks like. And notice that we call these if-then statements, whereas the pattern matching switch is an expression. So the difference is, in C#, an expression returns a result, whereas a statement doesn't return a result and simply controls flow. So you have the original switch statement, you have an if-then statement, you have a while or for each statement. Those are flow control statements, whereas pattern matching switch is a little different. It returns an expression, and you'll see how it works here in a second. So with an if-then statement, if you gave our input of an integer, we could say if it's 1, return lemon. If it's 2, return orange. If it's 3, return grape. Otherwise, default unknown. So there's a basic if statement. And if we were writing that with the original classic switch statement, it would look like this. Case 1, return lemon. Case 2, return orange. Case 3, return grape. And the default, return unknown. And the case syntax, to me, is not very much better than the if syntax, especially when you're not returning a value and you have to insert break statements or break keywords. So honestly, I never really did a lot of case in C#. I was always writing these if statements because they're fairly easy to read. It's literate programming, right? Most people can look at that and read it. Well, here's how you do that. I'm going to clean up my code while we're going. Here's how you would do that with a pattern matching switch expression. And in this case, this is called a constant pattern, meaning the pattern we are looking at is just a constant, in this case, an integer. So return input switch. And the way I remember this is that in the original switch statement, the switch comes first, and then the thing that you're kind of switching on in parens. And with the pattern matching switch, the thing you're switching on comes first, and then the switch keyword, and then and it doesn't go in parens. So we simply say return input switch, and then you get to use these arrow expressions, arrow functions. So if it's 1, give me lemon. If it's 2, give me orange. If it's 3, give me grape. And the underscore is known as a discard in pattern matching, and that gives unknown. So these 3 chunks of code do exactly the same thing. Like this is the classic switch. This is pattern matching. You can just see it's very concise and fluent and easy to read. I really like the style. And if you actually write this function as an arrow function, you can boil it down to that, where the return of as arrow function is, here's my arrow function, input switch, 1, 2, 3, discard. So that is quite lovely. So there you go. Now, there are other patterns. And one of the other sets of patterns, you have relational patterns and logical patterns that you can now use. So a relational pattern is like this. So less than 0 is a relationship between our switch variable and, in this case, a constant. So if it's less than 0, we return negative. If it's greater than, whoops, that's wrong, right? This should be equal 0, so there's a bug. If it's equal, I think, did I do it wrong? Now I've got myself confused. There may be a reason why I did it that way. If it's if it's greater than 0, greater than or equal to 0, return that. If it's greater than 0 and less than 10, return single digit. And if it's 11 or 13 or 17 or 19, return 2-digit prime.
Hey, Matt, real quick.
Are logical. Yes, sir. Yes.
That 0 rocket string 0. That's not
Yeah.
greater or equal to. That's the rocket operator.
Oh my
the
gosh.
greater than would be on the other side of the equal for greater or equal.
Yes, if it's 0. Oh my God. Thank you. Thank you. I totally got my brain twisted there. You're right. So this means greater than 0. This means equals 0. This means greater than 0 and less than 10. And this is our logical operators. Thank you.
You mean the first one? The first one is less than 0, right?
Yeah, less than 0. Yeah. So the one thing I like about this is that you get to use actual Boolean words instead of double ampersands or double pipes. Again, if you're a C++ programmer, that kind of syntax is just natural. You go with it. For other people, there's always a little hiccup there, and many programmers have a phase they go through where they don't double them, and it still kind of works, but maybe not. And so this is lovely because it just looks kind of a little more like SQL or like other languages that support the the words. So that's kind of nice. Okay, so
Sorry,
yes.
I got a question.
Yes.
Now I know this is .NET. They call it .NET Core now, I think.
They've gotten rid of the word core, so it is in that lineage. You're right, but it's just now called .NET.
That's called .NET, which is a different runtime than .NET Framework. So, because .NET Framework, like the later versions, they do have syntax like this, like for constructor initializers, or for you can have something that returns like an object without like instantiating the object. It's syntactic sugar kind of stuff. This looks kind of like that in that vein, although I really want to think of it as under the hood it's doing something similar, but I know it's not because .NET is different now.
We'll come to it. You can use this as a bit of a factory method to implement one. So give me a second. We'll get there, I think, and you'll see. So we had our constant pattern. We have our relational and logical patterns combined here. A very nice way to implement the constant pattern is with an enumeration, an enum. So here I have my breed enum, shepherd, retriever, chihuahua, and heeler. And so I'm passing in the constant here. I'm switching on a constant, which is the breed. And so we're just returning breed.shepherd, give us very smart. Breed.retriever, very gentle. Breed.chihuahua, very yappy. Breed.heeler, very energetic. And the interesting thing is you still need the discard, even though I kind of say to myself, can't the C# compiler figure out that there are only 4 breeds and therefore this will never happen? But I think it has to do with how enums are actually just really an alias for an integer, and you still need it. This doesn't at this point understand that the set is closed, so you still have to include that, or the compiler will complain. So I use this a lot. So here is the idea of using, in this case, again, the constant pattern, but instead of just like returning a string, let's return an object. So I've created a little data class called breed profile with a score for intelligence, aggression, noise, and energy. And then if you pass in a breed, you get back its profile. And it's using essentially a little, we're going to talk about this constructor syntax in another one of the topics with the target typed constructors. But you can see here, it's creating a breed profile with intelligence 10, aggression 5, noise 0, and energy 3. So as long as you can think of a way to return the value and use it as an expression, it's very flexible. One thing you should know is that you can use properties of the switch variable or switch object on both sides of the arrow function. So let's have a class here called dog, which has a breed and a name and an age. And I'm going to talk about this in a second. Init, I'll come back to that because that's another newish feature that's kind of interesting. So here we are giving the function a dog, and we're kind of coming up with a string based on the dog. And what you can see is on the left of the arrow function, we are using the age property of the dog. So with the relational pattern. So age less than 1 returns a string, which would be that dog, such as the name, like Fido is a puppy. And so we're also using the switch variable on the right. So it's employed both on the left and the right. Now, this is string interpolation, which I love, and we'll talk about it in a second. So if our dog is less than 1, it's a puppy. If it's between 1 and 3, it's a young dog. If it's between 3 and 8, it's an adult. If it's between 8 and 15, it's a senior. And if it's older than that, it's a miracle. So there's our little dog phrase. Here is so one of the things that if statements and case statements, traditional ones, do very well is flow control. And so you have, I want to take this situation and call another function based on that. So the problem with the expression is it has to return something. So the way you can kind of make this work is you need functions that return a value. You can't have functions that return void. So I've created 3 functions that each return a Boolean. Do this, do that, and do something else. And now if we give it 1, it'll do this. If we give it 2, it'll do that. And if we give it 3, it'll do something else. Otherwise, it's going to throw an exception in this case, saying invalid selection. So here I've created, I've kind of somewhat hacked this pattern matching switch into being flow control, just by saying, all right, I have to capture the result. And I'm not doing anything with the result here, though in the real world, you might. And then the last thing to note is that because async functions always return a task, they are natural for this kind of function dispatcher. So here we have something called pick an async function. And I've got 3 async functions: just a moment, which waits for half a second; give me a sec, which waits for a second; and hold your horses, which waits for 2 seconds. And then based on the selection, it's going to create the task T, either just a moment, give me a sec, or hold your horses, and then it's going to await that task. So that is really fun, and I've used that in production code as well. Okay, so that is pattern matching switch. Any questions? Oh, let me go. I thought I was going to tell you about init. Everybody knows about properties that are get, right? Auto properties where you can say public breed get, and it's read only. And we all know about public breed get set, where it's read write. If you do init, it allows you to set the value in your constructor expression, but then it becomes read only thereafter. So it allows you to do this, right? Where I can set the intelligence, the aggression, the noise, and the energy here when I'm creating my breed profile. But because they're marked as init, they can no longer be changed thereafter. I can't remember which version of C# that's in, but it's pretty new, relatively new as well. Okay, any questions so far?
I have a couple. I always will. First of all, I have a question about the task thing, just a general question. You explained it as using task as kind of a loophole, right? However, in real life, you're not going to use it as a loophole. You would use tasks specifically, right, for a async operation. So, like in real life, let's say you wanted to use void for this kind of thing, but you can't use that, right? I'm trying to just wrap my head around how the applicability of either one, if that makes sense.
async functions never return void. They always return text.
I know. No, I know.
Yeah. Okay.
I know
So it just,
all
yeah.
about
So it
these.
just means like here, maybe originally do this would have returned void because it was just go do it and there's no result. Well, that creates a problem because I can't really pick it. But if I change it to return a Boolean and just return true, again, it's a little bit of a hack, but then it allows me to use the pattern matching switch expression in this kind of way. If this was void, we'd have a problem. We couldn't do it.
Right, but you could say, I mean, the idea here, if it was void, would be, pick a function, like do something based on the input, and then it could just do the void thing, and you don't care. You just know it does the thing, and right?
Right,
Which is
and that's what
similar
I've done here. I'm swallowing this result isn't serving any purpose other
Yes.
than allowing me to use the switch, and this isn't returning the result.
Okay, that might be. Oh, yeah. Okay, I see. Okay,
It's kind of a funky little implementation detail there.
I think I'm just going to have to get more familiar with this, using this kind of thing.
Yeah.
The-
I encourage, again,
sorry.
the whole point is for you to event this is, if we walk away from this presentation and you're thinking, I might be able to use that, then download the code, play with it, then that's total success, right? I don't expect everyone to completely, absorb and internalize everything on the fly. So, yeah, it may be, Mo, that you'll just need to kind of, like we all do, just get your hands on it and then it'll start to make sense. Yeah.
Okay, so I have one more question. This one's not crazy like that. It's regarding the new thing with the instantiated parameters within it.
Yes.
This is different than, it looks like constructor initialization, except that with that you don't have the curved parentheses, you just have the curly braces, right? But here you have both.
Yeah.
So this is actually a different thing than that thing you're saying.
Yeah, I'm going to come to this. So our next topic, I think, is that.
Yeah. Matt,
Yeah.
just one more question, right? In the pattern switch, when we return, right, it's always going to be one, right? We can't have multiple statements.
Yeah, it returns. It can return an object. It doesn't have to return a value type, but it returns, and it could return. It could return a tuple, which we're going to look at.
Yeah, but we can't do like a multiple statement, right? Sometimes in the if condition or switch condition, we used to write multiple statement before break, right? Like for example, case aeroplane, some condition.
That's right. That's right. Exactly. You've nailed it. So if you want to do something simple, like just call a function, you're good. But if you wanted to you cannot write code in here. You cannot put curly braces and have a whole scope inside of there with multiple statements.
Got it. Thank you.
You could wrap that in this function, right?
Yeah, you're right.
You can have whatever it wants, but you can't inline it. So, yeah. So I am, pattern matching is a data-centric technique. It's a very old technique. I think Snowball or something in the 60s first introduced it, but it's become really popular in languages like Scala and Python, which are data-oriented languages, are very good. They're in the lineage of functional programming, and they have a lot of tools for dealing with arrays and sets and data. So that's where this comes from, and I think that's probably where the C# team took their inspiration and why they brought it in. I saw this and I was like, oh, I can do some fun stuff with this, but I would caution you to be like, well, if you're starting really to just replace all of your flow control statements with this, maybe you should rethink it. So and ultimately, the one you really, if you don't come away with anything else, it's this. This is just so many of us have written these really long. We've all seen it. These like pages and pages of if-then functions where there's 45 conditions. And it's almost like, shouldn't that just be data or a table? And that's probably a good way to do it, right, is to not have it in code at all. But if it is in code, you can replace that hellacious multi-page if-then with something really lovely and concise. Okay, in the interest of time, I'm going to move us forward. These are great questions. Thank you. I appreciate it. So, and this is probably the toughest or richest topic of all of these, so don't worry. They're not all going to take 30 minutes. Okay, so let's talk now target typed constructors. So in the dark ages of C#, before we even had the var keyword, if you wanted to make an object, things were a little bit wordy. So for example, you would do like list of string, my list equals new list of string. That's original C#. Or if you had a parameter in the constructor, list of string, my other list equals new list, and initialize it with 5 empty strings. Then when we got var or var, however you say that, all of the online examples changed and everybody's coding style changed, and we started doing this. Var my list equals new list of string, or my other list is new list of string with 5 elements. So why people like this is because this is like, why do I have to say this twice? Right? It's totally redundant. So you don't. Now, just for people who may not be quite familiar with the var keyword, it's not a variant. It's not an object. Okay, this is not like in JavaScript, a variable that's typed whatever, or it's not like old VB with the variant type, which can get assigned at runtime, or it's not even like the C# object. This is strongly typed. The compiler is doing this. So my list is a list of string. No doubt about it. It's strongly typed. It's just that it is a little less typing for you, the programmer. But I have always been a var or var resistor. I feel like there are certain situations where, and this becomes a religious debate where it just is a little harder to use. And I like having my types up front. I like seeing the type before the variable. I learned Pascal originally, which has them reversed. But once I made the switch to C#, I like it this way. So now with a target typed constructor, you can say list of string, my list equals new. And it will figure out that what you mean is new list of string. You don't have to say which constructor you're using. And if you want to use the one that has a parameter, that works too. So I am encouraging people who got used to this now to switch over to this. I think it reads better and it's more current. Now,
sorry.
I'm almost done. Just hold it. I'm almost done here, right? Because I think this will address your question from before. So this is an example combining the target typed constructor with property initializers. So again, in old C#, if you had original, this class thing with size, name, and is alive, and you didn't have this init keyword, and you wanted to initialize these values in the constructor and then have them be read-only, you would have to write a constructor, right? You would say public thing int size string name bool is alive, and then you would implement the constructor to say size equals size, etc. Right? And you would have a constructor that people could call, and then you would just make these read only. They would all just be get. So that works, but newer code uses this different style, which uses these property initializers, where if you have a property which is either settable or initable, you can use this syntax. And now instead of saying var my thing equals new thing, you just say thing, my thing equals new. And then within this expression here, or this statement, this scope, you can then use those properties, the property initializers, to set up your thing. It does the same, the end result is the same. It's just kind of a little more modern style and saves you from having to write these constructors. This is also helpful because so many of us do a lot of code where there is automagic JSON serialization and deserialization happening. Like if you're doing any ASP.NET web service or web website development, the framework is doing all kinds of JSON serialization and deserialization for you, and it really wants these POCO classes, these tiny data classes that don't have functions and constructors and methods. They're not fully realized objects in the old traditional object-oriented sense. They're just data containers. So this is kind of a style that matches that. Okay, I'm not saying never write a constructor. Just be aware that if you create your class like this, you can then do a lovely construction like that. Okay, questions?
I've asked a lot of questions. I have a few questions. If anyone else has, I'll let them go first because just for fairness. But if anyone else has, like, speak up. If no one else has, I'll say I'll ask my question. Question one is when you said new before in the page before, where you just said equals new or something like that, or the arrow new. So that was this syntax right here.
Yeah, I just took out the hard returns. I just made it on one line. It's this. I just took out some white space.
I think you did. Yeah, that's the same thing. And
Same
this is all right. And my other question is, the var thing is compile time. Later on, they introduced a dynamic keyword, which was runtime. Is this runtime as well? Doing it?
No. This is compile time. It just that the compiler infers the right constructor, and there will be cases. There are occasional cases where it can't figure it out, and you have to tell it. Every once in a while, you hit those.
I use the as keyword a lot, especially for using what do you call it, base classes and abstract classes and interfaces, just for decoupling and stuff. I use
Right.
as a lot.
Yeah, no, there's really, from the compiler standpoint, these three versions are identical. From the IL that's admitted, it's the same. This is all just about how you express yourself. All right, let's keep trucking. We got 20 minutes left. I want to stay on target. So the next one is value tuples. Or tuples, take your pick. So one of the challenges that all programmers have in any language is how do you handle the situation where a function needs to return multiple return values, like multiple pieces of data coming out of the function. So one classic original C# way of doing that is with out parameters. Out parameters let you pass multiple pieces of data out. So we have a function here that takes a date time going in and returns the month, the day, and the year of the date time. Or it kind of splits it there. So that's fine. Out parameters work. If you have more than 2 or 3, it gets pretty cumbersome. So, but we're all probably used to using them because things like try parse use out parameters. Another way, so what if I would do this if I went up to maybe 2 or 3. Past that, I'm going to make a class to capture the data coming back. This is a legitimate, or a struct, class versus struct. I have a video on that if you want to kind of delve into that. But the way this works is we're going to return this date part class. So again, I'm using that same syntax for the constructor here. A tuple is another way of solving this problem, which I really like. I feel like it's underutilized and underappreciated. So when you define a tuple or a tuple, these names are optional. So these are called field names. They are optional, but this is how it works. This is the tuple right there, and you're going to return one, just like that. So a tuple is just it's a value type. It's on the stack that has multiple kind of subvalues to it. So they're great. This is very efficient and elegant. From the perspective of performance and all that other stuff, probably makes no difference at all in most applications. But these are efficient because they are value types rather than objects. So there's no boxing or unboxing or any weird object manipulation. And they're just syntactically a little easier to use than out parameters. So I like that. And then the other thing just to make, that you need to know about is how C# handles tuple equivalence. And it is based on the values. So if I say int, right? I've left out the field names there. So if the 3int sort of array of values, t1, use a tuple as datetime.now, and then t2 is datetime.now, t1 will equal t2 unless I happen to do it right at midnight, right? Because the month, day, year of now will be the same, even though the milliseconds have changed, right? These two are the same. So from an objects, if you were looking at this from your frame of reference of objects, these are different objects. But because tuple equivalence is based on the values of the constituent elements, they actually are equal. So that's pretty nice, and it's important to know if you're going to use them. So those are tuples. Pretty straightforward. The next one in my list is string interpolation. So originally in C#, we would use this thing called string.format. So you would define a format string, like error messages or whatever. We'd say, okay, the something will something so many times at a certain date. And they allow you to format this. So I could have like this as a decimal with 1.5, and I can have the date be June 2nd, JUN 2, or something like that. But basically what you're going to do is substitute values in, and they're positional. The 0th value, the 1st value, the 2nd value, and the 3rd value. So using it looks like this. Return string.format, you give it the string, and then this open-ended args of values that can go in, and it matches them up. And it says, okay, my verb goes here, and my date goes here. So this works, and lots of languages support it just like this, C++, for example. But the problem is this position. First of all, it's a little hard to read, and second, you can have errors where you swapped your variables. Like if I swap the count and the date when I called the function, I'm going to get weird results, right? So it places a burden on the programmer to like read the format string, understand the order, and not screw it up. This is a really easy mistake to make, and I'm sure we've all made it. So string interpolation, which is inspired by a lot of, kind of, for example, web programming, where you see in JavaScript the like mustaches syntax, where you just inline the variable in the string and it does the right thing. So it looks like this. You start with a $sign to say I'm doing string interpolation, and then you just plop the variables in braces right where they go. And if you want to use your little formatters, you can. And if you want to, there's the formatter. So this one is probably worth seeing, right? So I'm actually going to run this one real quick, and I will choose the number 4. And you can see both of those functions return the same thing. The frog will hop 1.3 times on June 23rd. The code that did that, if you look back in the program, is just S equals format, use format, and S is interpolate with the same data. So I love this, and as soon as your friends who don't do C# realize that it has this, this is maybe the only possible thing that can make some other programmers jealous, because everyone thinks their language is superior, but this is really nice, and not every language has this. Okay, and then going back to the menu, the collection expressions with spread. I don't use this as much. So I would say I use string interpolation, target type constructors, and pattern matching daily in almost every new code. It just comes up. Tuples, okay, weekly. I make use of it, not quite as much. These two are a little more esoteric and special case, but I wanted to share them with you because they are very cool. So in C#2, if you wanted to make a list of strings, you would probably do this. Create the list of strings and then add the items to it. Iguana, wombat, and ringtail. And then it just prints them out with commas. And in C#3, once we got those object and collection initializers, we would say string animals is new. Well, you can't do that till C#9, but you get the idea. And then you have this initializer where you can kind of pass in the array that would get stuff. There is a list of string has a constructor that takes an enumerable or an array of strings, but this way you could specify it this way. And in C#12, it gets even more concise because you can use a collection expression like that. So my list of animals equals, and then you literally just kind of give it the array. So I love this. It's very concise. And then the spread operator is this thing. So dot dot array expands the elements of the array. So my mammals array is panda, peccary, porcupine. Dot dot mammals is panda, peccary, porcupine. So here I've got my mammals. Here I've got my reptiles, the Gila monster, the iguana, and the python, and my fish, my lanternfish, my guppy, and my chub. And when I make a list of animals using spread, you're going to get all 9 animals. So let me just show you that one as well. Let me compile the code. And we're going to do number 5. In there, you can see peccary, panda, peccary, porcupine, Gila monster, iguana, python, lanternfish, guppy, and chub. So that is the spread operator. That's kind of a esoteric thing, but it's cool. And the last one on the list is the null conditional assignment. Now, nulls in C# are a bit problematic, actually. And I feel like in some ways it's gotten worse with some of the options that are in there. But one of the problems, so in this talk, I am not going to go into all things nullable and null, right? I have some videos on different ways of coping with nulls. But one thing that a lot of us had to do in the past was something like this. Okay, let's say you have 2 things. One this is an object. So it's been initialized here. I have one, and it has not been initialized here. It's still null. And you may be wondering why, if you're very new to C#, why I don't have a question mark there, marking these as nullable objects. And it's because in my program, I've turned off the nullable, I've disabled the nullable stuff, so this makes this compile a little more like older versions of C#. So objects just are inherently nullable, and you don't have to tell it that they're nullable. So one of them is instantiated and one of them is not. And then we write this code like, okay, if thing1 not equal to null, then give it a name. Or if thing2, and then we have this, I forget which version, but we got this where you could say is not null, a little bit like SQL, then give it a name. So you have to you have to check the variable before you assign something, because if you just went ahead and did thing2.name equals Fred, if you just did that, right, it's going to blow up because thing2 is null, and you're going to get a null reference exception at runtime. So we're always writing this kind of code to guard and make sure our objects are instantiated before we work with them. Well, null conditional assignment lets you do this JavaScript-y type thing where you say thing1 question mark dot name equals Guido. And what happens is if thing1 is null, it doesn't attempt to dereference name. Or if thing2 is null, it doesn't try to dereference name. So there's your null conditional assignment, property assignment. And again, this is, if you want to use this, Right now it is in preview, so you have to set a lang version in your project and tell it to allow preview. You also have to download the latest update to Visual Studio for this to work. Okay, I kind of blasted through those. I think we covered everything. Now, if you want to see something again or have a question, we've got a little time for some dialogue.
I just want to say that nullable thing doesn't strike me as brand new. Like I feel like I've used it.
There's another yeah, I know what you're saying. And so on my YouTube channel, there are a couple of videos, and I might have to go look myself to remember which one it is. So this is a little embarrassing and weird self-promotion, but if I just go to my own channel and I go to the playlists and C# language features you should know about. So there are these null coalescing operators which look similar. And so again, if you know SQL, the concept of coalesce is if I give you A and B and C, and any one of them happens to be null, like A plus B plus C, if I was doing string concatenation, it's not going to throw an exception because one of them is null. Basically, it's going to return the first a coalesce returns the first non-null value in the set. So null coalescing operators, which look real similar, let you do that. Again, I would have to probably go back and review my notes on it. It's not something I do a lot on, so I'm not going to try to teach it here on the fly. But
Matt, can I comment on that as well real quick?
Please do.
So there's also something called the null conditional operator, which looks identical to this, but prior to this new C# 14 experimental, it only exists on the right-hand side of the equal sign or as part of an expression, not on the left-hand side as part of an assignment.
String, the name equals, yeah, that's right. Thank you. Thing1 question mark dot name. So do you put it before or after the?
It's exactly the same syntax. It'll be question mark dot name, and then if thing is null, it's like a quick exit and says, okay, we're returning null instead of executing anything to the right of that null conditional.
That sounds right to me.
Yes, thank you. Who said that? I wasn't looking at the screen.
Craig.
So
Thank you,
Craig. 40 points for Gryffindor. Thank you, Craig. So there you go.
Ravenclaw, thank you very much.
Will you come to my next talk? Just ride along, wingman. So the again, to explain for other folks, what's happening here is it's evaluating thing1, whether it's null or not, before it assigns the property over here. So this is kind of it's the same kind of technique, but in a different context.
Matt, I have a good question, right? So in this case, the variable the name will have the value of null, right? Suppose if we give thing2.name, then the name will be null.
Exactly.
Okay. So yeah, we can coalesce it also, right? That collation operator string name equals to thing2.name question mark that collation null collation operator. We can combine that one with this one.
Yeah, that the double question mark is the coalescing operator.
Yeah, so whether we can combine that one here, like think1.name is null, then I want to assign some other name, like a double question mark, like
yes.
that.
How do we do that, right? And honestly, at this point, when I'm stacking my question marks, I sometimes will pop back to the unary operator where I'll say, you're basically this, right? Name equals thing1 is null.
Yeah, Turner. Yeah, we do this one.
So like that.
Yeah,
And so this gets a little into like philosophy of coding. I feel like literate code is code that's easy to read, easy for someone else to understand your intent. And one of the problems with little tiny things like this that have massive impact is you may be really good and know exactly what this is doing, but a junior programmer or somebody who's newer or someone else, or you on a bad day, may not quite pick up on it. So I sometimes just resist trying to get too clever for my own benefit. I don't think this is overly clever. That's quite clear what it's doing. I wouldn't get too worried about it. But if I started chaining them, then I might think, well, maybe this is just more literate, right? It might be a little more typing, but your intent is very clear here.
got it. Yeah,
Yeah.
got it. Thanks.
Yeah. Now, one of the interesting things as we're talking about style, and while many of us are learning to make the most of GitHub Copilot and other AI-based coding assistants, is a lot of the data they were trained on does not include these newer features. And they may not suggest pattern matching switch or other things. That's been my experience, is that using GitHub Copilot is a little bit like having a programmer who is a little new to the game and stopped learning new stuff a few years ago. So not always, but just keep an eye out. That's another reason why it's nice to freshen up on this. So even if you're using an AI coding assistant to speed you up, there may be chances you can like refactor manually to get cleaner code. All right. Thank you guys so much for helping me out there and contributing. I love it. Other questions or comments?
Can you just put your GitHub back on the screen?
Yes. All right. So here's the slide. It's github.com, C# artisan favorite new features. And there's a in the C# artisan GitHub, there's another project which is related to SendGrid, which I have a whole video series on. If you kind of like the style and think it could help you out, there's a lot of content there, and it would be great if all of you would go subscribe to my channel and like a bunch of videos and do all those cool viral things. Again, I'm not monetizing this. It's more of an educational mission, but that's what helps it get visible. When you don't have an advocate like Sam who invites you, how do people discover this stuff? So that's how they discover it. Okay, I think that was it. Sam's put his camera back on, which is my cue to say thank you guys so much. Again, I appreciate the opportunity. This was really awesome.
Well, keep in mind, you have plenty of time, as much as you need. So that's the beauty of having a virtual presentation.
Okay, well, I can stop my share at this point. I mean, we can bring it back up if we need to. And we
Does
can.
anyone have any last questions or comments for Matthew?
Yeah, it's a great session. No, I feel like I saved a couple of days. Right? If I want to learn everything, well, definitely a couple of days, and it's like a piggyback, which is most needed. But tomorrow I can start using in my work. It's really worth time spending. Great, Mike. Thanks a lot.
I'm glad you liked it, Kingston. I'm glad it was helpful.
Yeah.
This was a great session. A lot of neat little sneaky things that are really cool. Thank you.
Thanks, Jan.
Not only did Matt do a great job with clearly presenting the topics, but also I applaud all of you for chiming in with questions and comments. It made it for a very interactive meeting. So great job all around, everyone.
Yeah.
And once again, thank you to Matt for taking the time to present. Just have a couple concluding slides before we adjourn for the evening. So if you look over into the chat window, you'll see that I posted a few links, and we'll go over those links in just a second. So first and foremost, the recording will be posted on YouTube in just a few short days. But if you would please subscribe to the channel to get the upload notifications. In addition, tech events, which we'll cover in just a second, are also going to be posted on my blog. And again, it would be a good idea to subscribe to that to get updates. I also post articles regarding AI and C# and a variety of other Microsoft technologies. Last but not least, if you would please take a moment to fill out the eval form. Again, the link for that is posted in the chat window. We'd like to provide Matthew with some constructive criticism. As far as events that are happening, so here you see a list of 4 user groups, all happening online virtually. On June 3rd is the Ohio North Database Training Group that's based out of Cleveland. However, it's a hybrid where they also have an online portion in addition to the in-person. So feel free to sign up for that. On June 5th, which is the first Thursday of the month, is the Azure Cleveland User Group. And on June 19th, which is the third Thursday, is the glug.net, also known as the Greater Lansing User Group for .NET users. And then lastly, on June 26th will be the June meeting of this group. As far as conferences, on August 1st on August 1st is Cincy Deliver, and that's going to be happening obviously in Cincinnati. That's going to be on a Friday. It's an all-day event of agile topics and various languages and platforms that are going to be presented. On August 13th through the 15th is the KCDC, also known as the Kansas City Developer Conference. And as you might have guessed, that's happening in Kansas City rather. And the link for that is also posted in my blog as well. If you're in the job market, strongly suggest you check out devitjobs.com. It's a great website where you can filter on the type of technology you want to work in, whether it's remote, contract, or full-time, and a variety of other attributes. So feel free to check out devitjobs.com. And if you need to get in touch with me, my email, snasser@nistechnologies.com. You can also find all my socials on Linktree/SamNasser. And lastly, my favorite platform, LinkedIn. If we're not connected on that, please, let's do so. I post a variety of different things, all related to the Microsoft platform, AI, C#, as well as tech events. So let's connect on that. And once again, thank you to Matthew for a great presentation, and thank you all for attending, and look forward to seeing you at the next June meeting. Good night, everyone.